Good morning student, myself Pungurli, welcome you for the Digital Principles and Computer Organization class. Today actually we are going to learn about the combinational circuit features, characteristics and the functions and the different types of combinational circuit. In that one of the example multiplexer we are going to learn thoroughly, and then followed by that the reverse operation of the multiplexer, that is demultiplexer. So if you see the combinational logic circuit or the circuits that contains different types of logic gates like AND gate, OR gate, NAND gate, NOR gate, XOR gate and XNOR gate. So the logical functions performed by the combinational circuit is fully defined by the set of Boolean expression. So if you see the characteristics of this combinational circuit, the N input variable comes from the external source while the M output variable goes to the external destination. In many applications, if you see the source or the destinations are going to be the storage registers. So the combinational circuit doesn't have any backup or previous memory. So the present state of the circuit is not affected by the previous state of the input. That is, we don't find any feedback from the output side to the input side. At any instant of time, the output of the combinational circuit depends only on the present input terminals. So these are the various types of combinational circuit: adder, subtractor, multiplexer, demultiplexer, encoder, decoder and magnitude comparator. Now we will learn thoroughly about the multiplexer. Okay, so multiplexer is otherwise called as a data selector since it selects one of many inputs and steers the binary information to the output line. If you see the block diagram, you'll be able to understand. So here we have 2 selection lines and 4 input lines and 1 output line. So now if you see, the multiplexer is going to be the combinational circuit that has 2 to the power of n input lines and single output line. N represents the selection line. So if in this example it is 4 cross 1, so n is equal to 2, 2 to the power of 2 is equal to 4. So I have 4 input lines and I have 2 selection lines and 1 output line. So if you're going to build this with a logic circuit, we are going to implement with AND gates, OR gates and NOT gate. If you see the truth table of this 4 cross 1 multiplexer, have inputs like selection lines S0 and S1, and I have one single output line. So the selection line is like the 2 to the power of 2 is equal to 4, already I mentioned. So it is 0 0 0 1 1 0 and 1 1. In that case, if it is 0 0 combination, then A0 will be selected, 0 1 combination A1 will be selected, 1 0 A2 will be selected, 1 1 A3 will be selected. So whatever the data available in A0, that will be transferred to the output. So the logical expression of the term y is as follows. So y is equal to S1 dash S0 dash A0 plus S1 dash S0 A1 plus S1 S0 dash A2 plus S1 S0 A3. Now coming to the 8 cross 1 multiplexer, here I have 2 to the power of 3 cross 1, that is 3 selection lines, and I have 2 to the power of 3 is equal to 8, so I have 8 input lines. So one of these data inputs will be connected to the output based on the values of the selection lines. Now since there are n selection lines, there will be 2 to the power of n possible combinations of zeros and ones. So each combination will select only one data input. So if you write the truth table for the 8 cross 1 multiplexer, so if the selection lines it goes S0, S1, S3, it is like 0 0 0, then my I0 will be selected. If the selection line is going to be 1 0 0, my I5 will be selected. So there are n selection lines and there will be 2 to the power of n possible combination for this with respect to zeros and ones. Now demultiplexer, the reverse operation of the multiplexer. A demultiplexer is a combination logic circuit that receives the information on a single input and transmit the same information over one of the several 2 to the power of n output lines. So demultiplexing is the process of taking the information from one input and transmitting the same over one of the several outputs. Here again I have 2 selection lines. It is actually 1 cross 4. So I have 1 input line and I have 4 output line. A, B, C, D are the 4 output lines. If you see the truth table of the demultiplexer, so here I have the input like enabled line, I have data input and I have selection lines S0, S1. Then in the case of output, I have 4 output lines Z0, Z1, Z2 and Z3. So now I am going to enable the line. If I am going to enable the line 1, then the data, whatever the data that has been available here will be sent to any one of the outputs based on the selection lines, that is S0 and S1. For example, if you see the second row of this truth table, if the selection line is 0, 1, then the data D will be available in the Z1 output. So if it is going to be 1 1, now the data will be available in the Z3. So that way the data that is available and the input side will be transferred to the output lines. So it is actually 1 cross 2 to the power of n demultiplexing. So hope you would have understood this. Now we are going for the applications of mux and demux. So the multiplexers are commonly used in communication system channel, telephone networks and computer memories. If you see, demultiplexers are used in communication system channel, reconstructions of parallel data and arithmetic logic unit. So I think you have understood this multiplexer and demultiplexer combinational circuits. Next class we will learn about the shift register. Thank you.